everybody. Good morning. My name is Mahmoud Mithat. I'm from Group 9. So today we are going to talk about pulse modulation and multiplexing. Let's start with introduction. So first of all, telecommunication networks are transitioning to a digital future. Several telecommunication components such as transmission lines and switches are being covered to function using a digital signal. As a result, information signals must be converted to digital format in order to be communicated across the network. There are several advantages and disadvantages of adopting digital modulation in telecommunication systems. We are going to first talk about digital modulation. What is digital modulation? The technique of embedding a digital information signal into the amplitude phase or frequency of the transmitted signal is known as digital modulation. The encoding technique has an impact on the transmitted signal's bandwidth and resistance to channel degradation. Digital modulation have several advantages and disadvantages. So first of all, let's talk about the advantages of digital modulation. First advantage of digital modulation is that it is easy to measure, store, and process. Second advantage of digital modulation is that it is immune to noise. Third thing about digital modulation is that it gives us the capability to have encryption. And fourth is that it's possible to multiplex. The disadvantage of digital modulation is that it needs to be synchronized. Second thing about digital modulation, which is to be considered as a disadvantage, is that it has a bigger bandwidth. Third thing about digital modulation is that is not compatible to an analog system. And fourth thing about digital modulation that is also considered to be as a disadvantage is that analog signal need to change to a digital signal first. Second thing we are going to talk about is sampling theory. The Nyquist sampling theorem asserts that if the waveform is sampled twice as rapidly as its highest frequency component, a band-limited continuous time signal may be sampled and properly reconstructed from its samples. And here we have three examples of sampling theorem. First is instantaneous sampling. It's not a very practical method, and sampling rate is infinity. Third thing is natural sampling. This method is practical. Sample rate satisfied by Nyquist sampling. Third theorem is flat top sampling. This method is also used practically. Thank you, and now I would like to pass the mic to my friend Riyad.
Hello everyone, so I'm Riyad and I'm going to represent you about pulse modulation. So what is pulse modulation? Pulse modulation is a type of modulation in which the signal is transmitted in the form of pulses. It is transmitted in the form it can be used to transmit analog information. In pulse modulation, continuous signals are sampled at regular intervals. Pulse modulation can be classified into two major types, analog and digital. Okay. For analog, it's the indication of sample amplitude is infinitely variable, and in digital, the sampling amplitude at the nearest predetermined level. It indicates the sample amplitude at the nearest predetermined level. Okay. Analog modulation is also classified in three types: PAM, PAM, PWM, PPM. PAM is pulse amplitude modulation. PWM is pulse width modulation, and PPM is pulse Gaussian modulation. And digital modulation, we have one type, which is pulse code modulation. Okay, pulse amplitude modulation. For pulse amplitude modulation, PAM, the message information is contained in the amplitude of the series of signal pulses in pulse amplitude modulation, and a type of which is a type of signal modulation. And amplitude of the train of a carrier pulses are adjusted according to the simple value of the message signal in the analog pulse modulation system. Pulse width modulation, which is also known as Pulse duration modulation is a technique for decreasing the average power produced by an electric signal by breaking it up into discrete portions. By rapidly rotating the switch between supply and load, the average value of voltage provided to the load may be regulated. Okay. And for pulse position modulation, PPAM, which is a single modulation technique in which messages M bits are encoded by sending a single pulse in one of the needed time shifts. This is done every t seconds, resulting in a bit rate of bits per second being broadcast to t, which as an interval can take for your sub. Pulse code modulation method used to represent an analog signal in terms of digital word constitute which consists three processes: sampling the analog signal, quantization of the amplitude of sample signal, coding of the quantized sample into digital signal. Okay, so let's go with the about the applications and advantages and disadvantages. Pulse amplitude modulation. The application which is for the PAMS, it can be used in Ethernet communication. It's also mainly used for it. Okay, it can be also used for microcontrollers to generate control signals. Used also in photobiology. Also used as an acts as an electronic driver for LED circuits. Okay, so advantages for this is both the modulation and demodulation are simple, and it's also easy for construction for transmitter and receiver circuits. Disadvantages: higher bandwidth is required for transmission, and the amplitude is very varying, so the power required is very high and more noise. Pulse width modulation applications: it is used for air traffic control system and telecommunication system. Remote control cars, planes, trains use pulse code modulations. Then it also used for compressed data, so it can be used as storage device, okay, for data. Then about the advantages, requires less power than PAM, but also can be separate easily separate signal from noise signal. It can be separated, and all the three types, it has the most power. It's the most power efficient. And for disadvantages, the system requires more bandwidth and it's highly complex. That's it for me, and my friend Iftar will go on with the further explanation about other pulse modulations. Thank you.
So here I will be talking about pulse code modulation. We can call it PCM. So here in the slides, here are some applications, advantages and disadvantages of pulse code modulation. So the applications are, it is used in the satellite transmission system. It is also used in space communication, used in telephony. One of the recent application is the compact disc, and the advantages are it is mainly used in long distance communications. Transmitter efficiency is more. It is higher noise immunity when compared to other methods, and disadvantages is more bandwidth is required when compared to analog system. And in this method, encoding, decoding, and quantization of the circuit have to be done. This makes it more complex. So now we will be talking about pulse position modulations, which is PPM. And in the slides, here is some applications, advantage and disadvantages of pulse position modulation. And applications are mainly used in Ethernet communication. Many microcontrollers use this technique in order to generate control signals. It is used in photobiology. It acts as an electronic driver for LED circuits. And advantages are low power consumption. It has an efficiency of about 90%. Noise interference is less. And disadvantages are the circuit is more complex. Voltage spikes can be seen. Switch losses will be more due to high pulse width modulation frequency. And the system is expensive as it uses semiconductor devices. Now we will be talking about multiplexing. So what is multiplexing? Multiplexing is a way of combining numerous analog or digital signals into one signal via a common media in telecommunications and computer networking. The goal is to pull a limited resource in telecommunications. For example, a signal cable can carry many phone calls. So here in the slides in the picture, we can see in 1870, telegraph invented in 1894, advanced to Biodox multiplex telegraph, and 1930, vacuum tubes improved to the multiplexing system. And 1950, best transmission speed was at 1200 bps. And 1960, vacuum tubes upgraded to transistors. And in this current time, many complex multiplexers invented at the rate of 10 GBs. So here in the slide, we will be talking about the types of multiplexers. So there are two types of multiplexers. One is analog multiplexing, one is digital multiplexing. And in analog multiplexing, there are two types of analog multiplexings, which is frequency division multiplexing, which is FDM, and wavelength division multiplexing, which is WDM. And in the digital multiplexing, there are one type of multiplex, three types of multiplexing, which is time division multiplexing, TDM. And there in TDM, there are two types of multiplexing, which one is synchronous TDM, another is asynchronous TDM. So what is analog multiplexing? So analog multiplexing is the analog multiplexing techniques involve signals which are analog in nature. The analog signals are multiplexed according to their frequency FDM or wavelength WDM. So what is FDM? In analog multiplexing, the most used technique is FDM. The technique uses various frequencies to combine streams of data for sending them on a communication medium as a single signal. And in the WDM, which is wavelength division multiplexing is an analog technique in which many data streams of different wavelengths are transmitted in the light spectrum. If the wavelength increases, the frequency of the signal decreases. So now, what is digital multiplexing? The term digital represents the discrete bits of information. Hence, the available data is in the form of frames of packets which are discrete. So TDM is the time frame is divided into slots. The technique is used to transmit a signal over a signal communication channel with allotting one slot for each message. Of all types of TDM, the main one is synchronous and asynchronous. So what is asynchronous TDM? In asynchronous TDM, the input is connected to a frame. If there is n number of connections, then the frame is divided into n time slots. One slot is allocated for each input line. In this technique, the sampling rate is common to all signals and hence same look input is given. And asynchronous TDM, in asynchronous TDM, the sampling rates is different for each of the signals, and the clock signal is also not common if the allotted device for a time slot transmits nothing and sits idle. Then that slot is allotted to another device, unlike synchronous. So now my another groupmate will be talking about after. So thank you very much.
Assalamu alaikum warahmatullahi wabarakatuh. My name is Mahdi Osman Abdullah. I want to proceed the last part of our presentation. For me, I want to record the multiplexers. Multiplexer application is analog broadcasting, digital broadcasting, telephony, and video processing, also telegraphy. In advantages, it reduces CKT complexity and cost. Also, we can implement many combinations logic CKTS using a multiplexer. It does not need key maps and simplifications. For on the advanced level, the ability of Max to switch directed SGA can be extended to smarter video, SG audio, SG etc. Disadvantages: added delays in switching ports, limitations on which ports can be used simultaneously. Uh, Also, extra input out many require to control multiplexers. The last one of the advantages are the delays in input output signals propagating through the multiplexer. For the next slide, recent advancement. What's 5G? 5G technology. 5G is a fifth generation of wireless network technology. It offers faster download and upload speeds and allows for more connected devices at the same time. Before 5G technology, superb connectivity for mobile devices, relatively fast internet speed of up to 100 Mbps or up to 4,000 devices supported per square kilometer. With 5G technology, superior connectivity designed for more types of devices. Aside from smartphones, expected download speeds of 10 GBs. 10 GBs. 100 to 1,000 times faster than the uh, preceding generation, up to 1 million devices supported per square kilometer. Health and safety misconceptions. Concerns about the risks of 5G are unfounded. Does 5G technology pose health risks? Experts have expressed that there are no factual basis for claims that say 5G poses risks to people's health, though more studies on 5G can be valuable. Consumers also need to be uh, educated more on how 5G works. That's all for our presentation. Thank you so much.